Hello, my name is Om, and in this video going to we are I will try and we are going to understand RAG from a blog which I have written. So in this uh, LLM now current era, many LLMs have adopted RAG because it provides more reliable and trustworthy answers. So it combines uh, a retrieval system. It is a technique which combines retrieval system and LLMs to provide more reliable and trustworthy answers. As and as it provides more trustworthy answers, it has been widely adopted. And even in we can places like ChatGPT plugins, like the custom GPTs which you see on the ChatGPT website, those also use RAG. So without RAG, you might already have noticed that LLMs can hallucinate a lot. If you provide something very specific, if you try to get answers from ChatGPT, if you ask questions, very specific questions related to some particular areas, or if you try to ask some questions based on latest information, like who won the semi-final for the women's ICC World Cup, Cricket World Cup. So it might not be able to answer those questions because the information is stuck at the point which from where it has been trained. But with RAG, we can improve that. We can make it more reliable, and it can also provide citations, so the information is more trustworthy. So what is RAG? So the name gives it all. Retrieval augmented generation. So the retrieval part is something which is retrieving. It has to retrieve. So there has to be some retrieval system. And uh, in these case, retrieval systems are generally some external data which we provide, or some private data, custom data which we will provide to this which we will provide to build the system. And then augmented generation. Augmented means we will after retrieving the data, we will augment it with the user query, and then we will proceed with the generation part. So we can see that without RAG, it will just take the user input, pass it to the LLM, and provide the output. But with RAG, along with the input, it will also uh, add some retrieved information from our custom data sources. So as a context, it will add to the user input, it will pass it to the LLM, and the answers, it will get the answers. So why do we exactly need LLMs? Why do we exactly need RAG? So the two main problems which we see, that the staleness problem, that whenever you ask questions, like latest questions or some very inform concept specific or very specific questions to a particular area, it may not be able to answer because its information is paused from where it has been trained. And the other is hallucination problem. Like if you try to ask LLMs about very specific uh, areas which it might not have been trained on, so it is very likely that it will try and guess, and it may or may not be correct. So to encounter these two main problems which every LLM used to face, RAG has been brought. So how this works? So how this actually works? So we will compare it with the normal LLM output, and with and without LLMs. So the old way is very simple. We will take the user query, pass it to the LLM, and we will get the answer. In this new way, we have to build first a retrieval system. Uh, then, based on this retrieval system, we will provide uh, context to the user query, and then we will pass it to the LLM. So first we need to build the retrieval system. So for that, whatever data we want the LLM to be trained on, like whatever data we want that LLM should be able to also know that from those data we need to build a retrieval system. So first is chunking the data, is like uh, dividing the data into smaller pieces or parsing it, then dividing the data into manageable pieces, and then embedding. So in this part, it follows similar to the vector space model. So each chunk or each part is then fed it into a model, a vector space model, which is converted into a vector or number, a high dimensional vector. And then it is then stored and indexed in a vector database. And we can see that why for this season also vector databases are on rise, like Pinecone and other vector databases, because all the major LLMs use this. So we can see the flow that we will collect the data, what we want to build the retrieval system on, parse it, and divide it into chunks, and then pass it to the vector space model, and it will convert into vectors. We will get those numerical vectors and store it somewhere. So after this retrieval system is built, uh, the generation part. So before the generation, we need to also convert the query into a vector form, because for retrieval, we need the query. So we will, when user inputs the query, we will take it and convert it into a vector from similarly how we converted the chunks into a vector. And then we will retrieve some key documents. We will match some similarity score. We can use any normal cosine similarity or any similarity algorithm to match the similar score. And we will, based on our architecture, we can retrieve top k elements, top k chunks, and those chunks or vectors, we will augment it with the user prompt. And then we will pass it to the LLM for generating the answer. So we can see that when a user query comes, we will pass it into the model which we created, retrieval system, and it will, from the model, it will search the database for similar, uh, for top k similar vectors. Then it will add as a context along with the query to the large language model, and then generate the answer. So we can see an example that here is some custom. Suppose we have trained a data based on some custom information. So when the user queries that what is project Kuiper and who is the CEO, so the system will first search the collection of data which we have provided, and then from this we can see that it has retrieved these two vectors or these two parts, and these two parts are passed along with this question, and then we can see the answers. So this is one uh, sample created answer. We can also see a real example. So here it is bit difficult to make the retrieval system. So I have taken from uh, an online video which that guy has made a retrieval system and like used Google's Vertex AI tool to make the system. If we have Google credits, we can also do it by ourselves. So here, first the user have created a custom document which he wants to be where he wants the retrieval system to be built on. So this is all. There is no way that Google can know what what is in this document. It is just it is not even real. It is just fabricated information which the user have created. And then first the user is passing a normal query without retrieval, without using RAG on the document. So the question is, what is the capacity of a Kym Kylem Starlight? So Kylem is a type of vehicle which the user have created by itself, and he is just asking that without using RAG. So we know that there is no way that Google can know what is this Kylem Starlight. So the first response without RAGs is, please provide information about the context. What is Campbell's Starlight? Is it a vehicle, ship, or something else? Now, using after performing RAG, so we can see the output. The Kylem Starlight 2024 has a cargo capacity of 13.5 cubic feet. And we can also verify it from the user document that yes, it has taken from this part where it is clearly mentioned that it is 13.5 cubic feet. So if you want to try, we can go to this uh, publicly available notebook file, and if we have some Google credits, we can try it by ourselves. Google provides a Vertex AI tool which generates the RAG by itself. So in this way, we saw that how RAG works. So where is RAG used in real world? So we might probably be already using it in our daily life, like in search augmentation. Like when you do some Google search, there is a new feature called AI mode in Google search itself. So it also uses the same feature as RAG. It uses the same uh, method as RAG. It takes the it takes the user query, and based on the user query, the pages are then uh, the top K pages which it might take. It is then based on those top K pages, it will pass it to its own Gemini or some model, and based on that, we can also see it in other models like ChatGPT or DeepSeek web search feature. And ChatGPT also has the custom GPTs feature, which is also based completely on RAG, where we can customly train our data, train our data based on custom, build a retrieval system, not exactly train, build a retrieval system, and then pass it along with the LLM to get specific or reliable answers. It is also used in question answer chatbots, like you see on websites when you visit some websites like Amazon or some shopping website. You can see that there is a chatbot available, which is mostly it is trained on custom the e-commerce website specific data, like based on their policies or uh, product specifications and other things. And other use case can be knowledge engine. So if we want to if we want to ask questions based on some custom our private company specific private data, so it can also be done using RAG. So as we know that RAG combines both retrieval system and LLM, so it can be used in applications where just previously only LLM was used, and or previously where only retrieval were used. So we saw here that in search augmentation, in previously only just we used to type in ChatGPT, the older versions, ChatGPT 2 or other versions. It did not have the search feature. But now we can see that it has a web search feature. So in those use cases, and in use cases where first only the retrieval system were used, like if we are using some if some companies are there and those have long specification documents. So first, they might only be using the retrieval system to get some information, but they can also now incorporate LLMs for also chatting with those custom data. So that's it on retrieval augmented generation. Thank you.